Now in this session I am going to discuss compressible flow, uncompressible flow, and thereafter we will discuss the rotational and irrotational flow. Okay, so in the last class we have already discussed uniform, non-uniform flow, okay, and laminar flow and turbulent flow. So number 5, it is number 5, that is type of flow. We are discussing type of flow. Okay, so compressible and non-compressible flow. Okay, see, compression is about changing the volume. Okay, compression means changing the volume, dV by V, and it is related with the bulk modulus. Okay, it is related with the bulk modulus, and that compression change in volume related with one Mach number, that is called Mach number fluid velocity by sonic velocity. That also we have already discussed in the fluid properties. Okay, so compressible flow, a flow in which that is related with density also. See, density is constant. See, this is nothing but mass per unit volume, and this volume is related with this volume. Okay, and this is related with bulk modulus, so it is compressibility effect also. So a flow in which density remains constant, that is, density does not change. That type of flow, density is fixed, density remains constant. That type of flow is called incompressible flow. See, density means mass density. If you are not changing the volume, so there is no change in density. So what I have written here, flow in which density remains constant. Density is fixed because you are not changing the volume. And if density is fixed, density does not change. Density is constant, so there is no change in volume. So you cannot compress the system. So that is called incompressible flow. Example for which we can call it as hydraulics. We are going to discuss turbines. Okay, fluid turbines, pumps, fans, blowers, all these things. Okay, so they are going to discuss. We are in hydraulics. So liquids, generally liquids are incompressible fluid which we cannot compress it. Okay, density remains constant. Another is incompressible flow, a flow in which density changes. Density, here we can call it as like this, density constant. Okay, that is the density constant. See, density does not change, so density constant. So that is for incompressible flow. A flow in which density changes, that type of flow is called compressible flow. That type of flow is called compressible flow, where density is not constant. Am I right? So that is not constant. And example for which we can consider like missiles, rockets, all these aviation parts which we are going to use. Air, see, remember, air we are going to use, that air is compressible. You can change the volume. So density is not the constant. And that type of flow is called compressible flow. Another criteria is also we have already discussed. If Mach number is less than 0.3, it is incompressible. And if it is Mach number is greater than 1, up to 1, sonic. Okay, that is Mach number compression. So fluid velocity will be equal to sonic velocity, that is Mach number 1, sonic velocity. And this is, if Mach number is 1, So that is called maybe supersonic and hypersonic. Supersonic or hypersonic also. Okay. Hypersonic. That difference is if it is up to 5, 1 to 5, so it is supersonic. If greater than 5, so it is hypersonic. So that depends upon also this is incompressible. This is incompressible and these are compressible flow. So as I told you, compressible and non-compressible flow depends upon the Mach number also. If Mach number is less than 0.3, they are called incompressible flow, where fluid velocity will be less than sound velocity. When fluid velocity and sound velocity relation Mach number is greater than 1, up to 5 it is supersonic, and greater than 5 it is hypersonic. They are called compressible flow. Okay, because rockets, missiles we are going to use, and their Mach number is greater than 1. So that way this is compressible and incompressible flow. Last type of flow is rotational and irrotational flow. Rotational and irrotational flow. Irrotational flow. See, I am giving you one example. This is a rotating cylinder viscometer where fluid is rotating. Okay. Flow is along the streamline. Okay. Another is, see, from the tanki, water is flowing like this. Now, tap is there and water is flowing like this. Okay. See now, this is flow is along the streamline. Remember, flow is along the streamline and rotates about its own axis. Flow is along a streamline and rotates about its own axis. That type of flow is called rotational flow. Okay, rotational flow. See now that is, it is also called forced flow because it is flowing inside the rotating cylinder viscometer. Rotating cylinder fluid. Okay, so that type of flow is called rotating cylinder, rotational flow. Irrotational flow means, see here, it is also along the streamline. Along a streamline is there, but it does not rotate about its own axis. It does not rotate about its own axis. Okay, that type of flow is called irrotational flow. That is irrotational flow, for which example you can take emptying wash basin. Okay, here also flow is along the streamline, but it does not rotate about its own axis. That type of flow is called irrotational flow. Example is emptying the wash basin. Rotational flow means the flow is along the streamline and rotates about its own axis. Okay, that type of flow is called rotational flow. And it is also called forced flow. It is called free flow also. Okay, this way I have completed your all types of flow. First one was one-dimensional, two-dimensional, three-dimensional, steady, unsteady, then uniform, non-uniform. Number 4, laminar, turbulent. Number 5, compressible and incompressible flow. And 6th one, this is rotational flow. By this way, I have completed your all types of flow. Rest of the thing I will discuss in next class. Thank you.